Fusion Mobile, quality e-learning experience on the go.
Welcome to Fusion Mobile e-learning clinic. My name is Sonia Laloa and I'll be walking you through the physics class. We want to consider heat energy. And in this particular session of heat energy, we'll look at the measure of temperature, and we'll be taking the subtopics. The first one is heat and temperature, and then we'll look at construction and graduation of liquid in glass temperature thermometers. Then we'll look at the types of thermometers and thermometric substances before we'll look into the comparison of thermometers. Then we'll look at thermometer and temperature scales, and finally molecular explanation of temperature. In a previous lesson we talked about heat, and we explained that heat is a form of energy which is made obvious by temperature change. I also remember mentioning that it is not all times that heat is applied that a temperature change is observed. We describe temperature as the degree of hotness or coldness of a body. So, we want to look at the differences between heat and temperature. Many times, when there is heat supplied to a particular body, temperature change occurs. But when the body is trying to change states, that is, it is changing from the solid state to the liquid state, or from the liquid state to the gaseous state, the temperature remains the same while heat is used to transform the state of the body. This particular heat at this particular point, the particular heat required at this particular point in time is known as the latent heat. The differences between temperature and heat, some of them include the fact that heat is an energy, temperature is not an energy. Temperature is just a degree of coldness or hotness of a body. Also, heat is measured in joules, which is a measurement, the unit for measuring energy, while temperature is measured in Kelvin. That's the SI unit for temperature. Also, we have other scales such as Fahrenheit, the Celsius scales, which is also known as the centigrade scale. Heat can cause physical and chemical changes, while temperature is just an observation of what is happening around. It is not inducing any change, it is created by heat. So from the table on your screen, you can see the differences between heat and temperature. Heat is a form of energy, while temperature is not. Heat can be responsible for chemical or physical changes, but temperature is just a measurement of whatever changes changes in terms of hotness or coolness of a particular location. And heat is measured in joules, temperature is measured in Kelvin, that's the SI unit for temperature. It can also be measured in degree Celsius or degree Fahrenheit. So let's consider the differences between temperature and heat. A table will be on your screen in a few seconds showing the differences between temperature and heat. From that table you would see that temperature is a measure of degree of hotness or coldness of a thing, but heat is not. Heat is actually a form of energy, thermal energy. Temperature is not an energy. Heat is measured in joules, while temperature is measured in degrees of Kelvin, or degrees of Fahrenheit, or degrees of centigrade or Celsius, which is the Celsius scale. Heat is associated with physical and chemical changes, but temperature is not associated with any kind of change. Rather, it is just a measure of whatever changes may have happened. Heat actually causes work to be done. In terms of temperature, temperature can be used to estimate the work that is done, but it is actually heat that ensures that the work gets done. So heat does work, temperature cannot do work. Let's consider different types of thermometric substances. Thermometric substances, what do we mean by thermometric substance anyway in the first place? First thing to understand is temperature is measured using a device called a thermometer. And in the design of thermometers, we have to understand how different materials behave when they are exposed to varying temperatures, when they are exposed to heat. Of course, when heat comes, it alters the temperature of a particular location. So when these materials are exposed to varying temperatures, they react in different ways. We have four different methods in which we design thermometers. The first one is known as the liquid in glass thermometer. That's the first type of thermometers, the liquid in glass thermometer. These are the most common types of thermometers we see around. The clinical thermometer is a good example of such. It contains the liquid, that's mercury, inside a glass tube. Now, when the temperature of a body increases, the liquid inside the glass expands. So a reading can actually be taken from that. We also have the gas thermometers. Gas thermometers also, they have gases in them. They have one particular gas would be inside the apparatus, and when there is a temperature change, the gas would expand, causing us to have a kind of reading. We have the electric thermometer. Of course, all this will be showing on your screen right now in the table. We have the electric thermometer, which actually uses resistance to calculate, to estimate the temperature. We have the thermoelectric thermometers also, which actually uses varying electric currents to estimate the temperature of a body. I've spoken about heat and temperature. Some questions will pop up on your screen in a few seconds. Please do well by answering them. Construction and gradation of liquid in glass thermometer. I said earlier that the most common type of thermometers we have around are the liquid in glass thermometers. Yes, we have a couple of them. The Fahrenheit temperature, the Fahrenheit thermometer actually is a liquid in glass thermometer, and the Celsius scale thermometer or the Kelvin thermometer is also liquid in glass thermometer. While the Fahrenheit thermometer has alcohol inside the glass, the Celsius scale or the Kelvin temperature thermometer have mercury in the glass. So both of them have something inside the glass tube. So how do we go about constructing the thermometer? A glass tube will be gotten. The glass tube will have a bulb at the base region. The purpose of the bulb is to accommodate the excess fluid, that is the liquid which we put in the glass. So when there is a temperature change, the liquid in the glass would expand and will climb up the stem of the temperature of the thermometer. So how do we do the gradation of the liquid in glass thermometer? Well, there are two temperatures points that are very, very important. These are the low points and the high points. The low point, these are the two fixed points of every thermometer. The low point is a ground point, and usually is taken as the freezing point of water. The low point is a ground point and is taken as the freezing point of water, which is described as 0 degrees Celsius. 0 degrees Celsius is the same thing as 273 Kelvin, and it is also the same thing as minus 32 degrees Fahrenheit. 0 degrees Celsius, same thing as 273 Kelvin, and same thing as minus 32 degrees Fahrenheit. That is the lower point, which is the freezing point of water or the melting point of ice. To take this particular measurement, after the liquid has been put in the glass, an ice setup, as you're seeing on your screen right now, the setup will be done. You put some ice inside a funnel, and why we're using the funnel is so that whatever water is coming out can drain out of the system, instead of the water to begin to alter the temperature of the system. So the water drains out, we only have the ice. Since we know that the temperature, the heat that is being absorbed by the ice during this period is the latent heat. That is the type of heat that does not cause temperature change. So as the ice drains off, as the ice begins to melt rather, the thermometer would begin to take a reading, and to get to a point it would stop moving. That it will be at what should be our 0 degree Celsius. That is the melting point of ice. That point should be marked. It should be marked on the glass tube. Then we'll go for the next point. The next point is the boiling point of water. The boiling point of water. The boiling point of water is set at 100 degree Celsius, which is the same thing as 373 Kelvin, which is the same thing as 212 degree Fahrenheit. That's the boiling point of water. The boiling point of water. So, how do we get this measurement on our temperature, on our thermometer? Very easy. The same setup, another setup will be blown on your screen in a few. Now, in this particular setup, something similar to what we had the first time would be done, but only that this time around, instead of us having ice, we would have a setup where we have water that is being boiled. It's being boiled. The water will have an heat source will be beneath the water, and the thermometer will not be allowed to enter into the water. So it will be taking the measurement from the steam. Yes, it will be taking the measurement from the steam. Of course, the entire setup has to be covered. It will be covered, and an insulator as a heat insulator will be kept around the cover so that the thermometer does not begin to measure the temperature of the metal casing in which the heating process is taking place. Now, as the water is boiling, the liquid in the bulb of the thermometer would begin to rise, and to rise to a certain point, which should be marked as the boiling point of water on the thermometer. After taking these two fixed point measurements, every other measurement can be done by marking out the distance. Every other measurement can be done by dividing the distance between the melting point of ice and the boiling point of water into whatever number of scales one wants one's temperature to have. If you're working with mercury, that means you'll be having something similar to the Celsius and the Kelvin temperature scale. You'll be having something similar to the Celsius and the Kelvin temperature scale. You can make your scale to 100 degrees. You can make your scale to 50 degrees. You can make your scale to 5 degrees. But it is better to, the larger the degrees, the number of degrees you insert into your scale, the more accurate your the temperature you're trying to measure would most likely be. While conducting these experiments, there are some precautions that should be taken. The first is that you should ensure that the thermometer being inserted into the funnel containing the ice cube is standing vertically. That is, it is erect. If it is slanted, there is a chance that the liquid in the glass may not be able to move properly. Both in the thermometer should be allowed to stand erect, either in the glass, in the funnel, or in the vapor chamber. Also, it should be noted that the thermometer must not make contact with water when you're working with when you're working with both the ice and the vapor. That it must not make direct contact with water. When it makes direct contact with water, the water on the thermometer might actually dry off and it may begin to take an erroneous measurement. Also, it should be ensured as well that when this experiment is being conducted, it is conducted at the normal atmospheric pressure. When this experiment is being conducted, it is conducted at the normal atmospheric pressure. This is to avoid errors, because when pressure has an effect on temperature, temperature also affects pressure. So both of them affect each other. When the pressure at that particular time is not the atmospheric pressure, the thermometer readings may not be correct when you're trying to use it to take measurements afterwards. Thermometers. Let's talk about thermometers. Earlier I said that there are different types of thermometers, and I mentioned 4 different kinds of thermometers that we have. That's the liquid in glass thermometers, we have the gas thermometers, the resistance thermometers, and the thermoelectric thermometers. We can also use bimetal strips or metals to also create thermometers. It's just that the measurements may not be so very accurate. But let's look into the principle behind the application of all these substances. Well, what are the features that a normal thermometric substance should possess? A good thermometric substance should be sensitive to heat. That is, when there is a slight change in temperature, a good thermometric substance should change either in volume or it should change in quantity. A good thermometric substance, when there is a slight change in temperature, the thermometric substance should change in quantity. That is how we pick thermometric substances. Anything can be used to make a thermometer. I can decide that I want to make a thermometer that has inside it just water. But there are certain features that I must also put into consideration. Alright, let's see some of the thermometric substances and the principle of operation. The liquid in glass thermometers, they work under the principle of expansion of volumes. Though what you measure is something on a straight line, and that's because the liquid is being packaged into very tiny, the stem of the thermometer is actually very thin. It's actually very thin, so the volume expansion is not really observed as volume expansion, rather it is noted as length extension. Yes, it is noted as length extension. So a good liquid in glass thermometric substance should possess the following things. It should be very sensitive to heat, which means it should have a low specific heat capacity. A low specific heat capacity talks about the ability of a high specific heat capacity. Specific heat capacity talks about the rate at which substances expand when temperature changes. So when little temperature change occurs, the material should expand greatly. The material should expand greatly. The clinical thermometer is graded between 25 degrees Celsius and about 43 degrees Celsius. This temperature scale is indicated on a clinical thermometer that can be as long as 15 centimeters. And the benefits, the reason why this is possible is because mercury is used in the system, and that's because it expands very much when little temperature changes occur. And also, color would be very nice since the glass is transparent. So it would be very good if the substance were to be a liquid that has a color of its own. Apart from that, liquids that have a higher cohesion force, that is, that do not stick to glass or do not in what we call wetting of glass. I remember when we were talking about fluids, we talked about capillarity and we said capillarity is we talk about capillarity as the movement of fluids, of liquids in thin capillary tubes. So when water is put in a glass, you see it forms something like a U. That is, it is wetting glass. It is sticking to the walls of the glass. When it sticks to the walls of the glass, there may be a confusion in the reading because the temperature might have actually changed, but because it has stuck to that particular point, you may not be able to observe the temperature change. But when you're using something that does not wet glass, like mercury, which does not have a U, rather it has an N, immediately there is a temperature drop, it's falls. And when there is a temperature rise, it rises. So those are some of the advantages of mercury over water and other substances that can be used as thermometric substances in the liquid in glass thermometers. The gas thermometers. In the gas thermometer, what we have is a gas that is being packed and stored, that is being compressed in a particular container. Now that container part of the glass is where is the part that will be exposed to the heat, and a kind of pressure connection, knowledge of pressure, the principle of pressure is being applied. Of course, we will be dealing with gas laws very soon. That will shed further light on the principle of operation of gas thermometers. In the resistance temperature thermometers rather. In the resistance thermometers, substances in the resistance thermometers, substances which offer resistance to the flow of current when electricity is being passed through a circuit, that are also very, very sensitive to temperature, are used. These substances, they grow, they become larger and increase in their resistance to temperature, to the flow of currents. There is an increase in the resistance of the substance to the flow of current when temperature is increased, and a reduction in the flow of in the resistance offered to the flow of current when temperature falls. So they use the principle, the principle of expansion and contraction to offer resistance. That is, knowledge of their resistance increasing or decreasing based on temperature increase or decrease. We use that to calculate the temperature at that particular time. Of course, to design such a system, you must also conduct the kind of liquid in glass thermometer experiment. That is, you have to note the freezing points and the boiling point. You must know the fixed points of the system before going ahead to use it. Similar to the resistance thermometers is the thermoelectric thermometers. Only difference is that in the resistance thermometers, it is the resistance that is being observed. But in the thermoelectric thermometers, what we take note of is the electric current. The amount of electric current that is flowing would be measured, and it will be used to estimate what the temperature at that particular point in time is. These kind of thermometers can actually measure extreme temperatures, very high temperatures, and very low temperatures, because they involve the use of solids in their operation. Solids that would not vaporize at temperatures very, very low, or melt or dissolve at temperatures that are very, very high. We also have the bimetal strip thermometers. The bimetal strip thermometers have two metals, one which does not expand easily, that is, it would maintain its size over a very long duration, and one which is sensitive to temperature. The one which is sensitive to temperature will grow in size as temperature increases, while the other one maintains its size. Thereby, we are able to reach the new temperature reading by the expansion of the sensitive one on the insensitive one. Comparison of thermometers. Well, we have talked about different types of thermometers, their methods of operation. But let's look at the generally now. Why should we choose one particular type of thermometer over the other? Or is it that we can use all kinds of thermometers at the same time? Well, we cannot use all kinds of thermometers at the same time. Just like when we started this course, I remember mentioning that we have to use specific kinds of measuring tools to take measurements. You do not want to use a stopwatch to time yourself running from, taking a vehicle from Lagos to Ibadan. You would want to use a wristwatch because your measurement will be in hours and the stopwatch take measurements in seconds. So in like manner, you don't want to use a thermometer whose gradation ends at 43 degrees Celsius to measure the temperature of a coal that is being placed on the fire. You will not be able to get the accurate measurement. In like manner, you don't want to use your extreme temperature measuring tools to measure the temperatures which have just very slight changes, like the temperature of the human body. You wouldn't want to use a temperature scale that will measure up to 1,000 degrees Celsius to measure the temperature of a human body. It would not give you something accurate enough. So how do we choose what thermometers and what? Let's compare the thermometers one with the other. Now you should have a diagram, a table on your screen. Yes, from the table on the screen, we have the first one up there is the liquid in glass thermometer. The liquid in glass thermometer, that's when we use the mercury in glass thermometer. We use mercury because that's the best of them all. The mercury in glass thermometer can measure temperature ranges between minus 39 degrees Celsius and as high as 353 degrees Celsius. Minus 39 degrees Celsius and 356 degrees Celsius. The advantages include the fact that mercury is opaque. It has a color of its own. And it does not evaporate easily. It does not wet glass as well. And at the same time, it is very, very sensitive to temperature changes. When a slight change in temperature occurs, mercury would move. The disadvantages include the fact that mercury freezes at minus 39 degrees Celsius, which means any temperature below that, the mercury will not be able to indicate it. So we won't be able to take measurements below minus 39 degrees Celsius with the liquid in glass, with mercury in glass thermometers. Also, it is very fragile since we have the mercury put inside glass. When we should drop, it can break easily, and it would not be very accurate when we are taking certain kinds of readings. Yes, it will not be very accurate when you're taking certain kinds of readings, such as extreme temperature readings. Your mercury in glass thermometers won't give you that accurately. Let's talk about the resistance thermometer, the platinum resistance thermometer. The platinum resistance thermometer is used to take measurements of temperatures between minus 180 degrees Celsius and 152 degrees Celsius. Yes, that's because of the nature of the material. Now, the most interesting advantage is the measurement is very accurate. That is very, very accurate. It measures accurately very low temperatures and very, very high temperatures. Now, the disadvantage is the time involved. When you are trying to take temperature, the time involved in the measurements, it might take a longer period of time. And you know, temperature changes happen abruptly. The temperature of a particular place can be about 35 degrees Celsius right now, and in the next 15 minutes, it can be as low as 29 degrees Celsius or even 25 degrees Celsius from 35. Maybe due to cloud cover or emergence of rain. So platinum platinum resistance thermometer may not be very good for measuring temperatures that change very abruptly as that. Next one we'll consider here is the thermoelectric thermometers. Thermoelectric thermometers can be used to measure temperatures ranges between -100 and 250 degrees and 1155 degrees. -250 degrees and 1155 degrees. The advantages include that it has a wide range of temperatures. It also measures momentarily and it is very sensitive. Of course, when the material when these changes occur, since we are considering currents, it is not really based on the nature of the material. It's any slight change you can observe it, and this is one of the materials that is used to. This is one of the methods that is used to take measurements of space objects, such as surface temperature of the sun and surface temperature of different planets. Of course, it also allows small size measurements. It also allows small size measurements, even though it measures a very wide range. The truth is, the disadvantage, the temperature reading might not be very accurate. Why might it not be accurate? Since we are measuring the electric currents, our equipment for measuring the electric currents can also be affected by heat. Temperature changes can alter the accuracy of the current which is being measured. So that is the disadvantage. But if the heat or the temperature is not in direct contact with the machine which is being used to take the measurement, that is with the thermoelectric thermometer, the accuracy is higher. At the constant volume gas thermometer, it measures between the range of -270 degrees and 1500 degrees Celsius. All the temperature scales have been used in this lesson have been the Celsius scale, because that's a system. It's until not too long ago that the Kelvin scale became adopted, but the Celsius scale is what we've been very used to. Now, this type of thermometers are very sensitive, they are very accurate, and they measure wide ranges. In fact, they are the ones used in the calibration of most of the other types of thermometers. Now, the problems, the disadvantages, the setbacks that could probably come up is the complexity of setting up this thermometer. The complexity of setting it up and reading it, that is until you have actually done the gradation of the constant volume gas thermometers is very tedious, is very complex, and also knowledge of pressure really is very, very important. So if there is any alteration in atmospheric pressure, it would actually affect the measurements taken from this particular system. As I said earlier, more often than not, what we use in metrology and in the medical line is the liquid in glass thermometer because of the temperature range in which we operate. We operate mostly between 0 and 100 degrees Celsius. So due to that, we need to also take note of substances, that is liquid in glass thermometers. We have two major types of liquid in glass thermometers. The one which forms the Fahrenheit scale, which is alcohol, and one that forms the Celsius scale, which is mercury. So let's look at the advantages of one over the other. On your screen right now, you have a table showing the mercury in glass thermometer and the alcohol in glass thermometer. Talking about mercury in glass thermometer, it freezes at about 39 degrees Celsius. That is a strong disadvantage for it, which means it does not allow us to take measurements of very, very low temperatures. But the alcohol freezes at about minus 115 degrees Celsius. That allows us to take temperatures even much longer after our mercury in glass thermometer has stopped working. Yes, mercury has a lower expansivity compared to alcohol, which means when you want to take measurements, if you want a more accurate measurement, it's better to use the alcohol, because the amount of expansion that will be noted is more obvious in the alcohol compared to in the mercury. One mercury will be giving you about 1 centimeter increase or 1 millimeter increase. Alcohol would give you as much as 6 centimeters or 6 millimeters respectively. Also, when it comes to vaporization, mercury is not easily vaporized. That is one advantage of mercury over alcohol. Alcohol, even if you leave it open, it begins to vaporize on its own. So that means the alcohol would not be able to measure temperatures very, very high effectively compared to mercury. And also, alcohol is difficult to see. You might actually need to add a color to the alcohol, since alcohol is a clear, transparent liquid. But mercury has a color of its own. It is red, crimson red in color, so it is easy to see it rise or fall within the glass. Also, conductivity. The conductivity of mercury is much greater than that of alcohol, and the fact that alcohol wets glass, but mercury does not wet glass. So, which means after taking a particular measurement, alcohol more likely stays at that old measurement until maybe you vibrate the apparatus. But mercury, it has a higher cohesion force, so automatically after taking a measurement, once the temperature changes, it begins to drop instantly to the new temperature. Okay, let's talk about temperature scales. We've been focusing so much on liquid in glass thermometers because that's what we use around the most. And I've made mention of 3 different temperature scales which we have in the liquid in glass thermometer, or in temperature that we use generally. What do we even mean by temperature scales? Temperature scales are like the unit for measuring our temperature. Just like we have meters for measuring lengths and inches also for measuring lengths, we also have something like that in temperature. We have the Fahrenheit scale, that's measured in degrees of Fahrenheit. We have the Celsius scale, measured in degrees of Celsius, and we also have the Kelvin scale. In Kelvin, we do not use degrees. Now, what is the difference between all these things? The first thing to note, I told you talking about graduation of we're talking about the construction and graduation of thermometers. I made mention of the fact that you have to consider the fixed points. I said the fixed points are the boiling point and the melting point of water. Yes, we use water because that is a generally available liquid. So the melting point of melting point of ice. Sorry, let me use boiling point of ice of water. Boiling point of water and melting point of ice. These are the 2 extreme temperatures that we do use in the design of our systems. Now, for each of them, they have different values that are allotted to these points. In the Fahrenheit scale, the melting point is minus 32 degrees. In the Celsius scale, which is centigrade scale, the melting point is 0 degrees. But in the Kelvin scale, on the Kelvin scale rather, it is 273 Kelvin. While in the Fahrenheit scale, boiling point is set at 212 degrees. In the Celsius scale, it is 100 degrees. In the Kelvin scale, it is 373 degrees. 73 Kelvin. We do not work with degrees when it comes to Kelvin. So, having noted this, then how do we now determine the temperature of a body at a particular point in time? Peradventure, we have maybe one particular thermometer and you want to measure your temperature in another graduation scale. So how do we go about it? Let's say I have my temperature here at X. I want to know what is going to be this at this particular point, which is also at this particular point. Let me call it X here, let me call it Y here, let me call it Z here. Alright. To calculate inter-temperature scale measurements, the formula to use is we do the difference of the temperature of the boiling point and the temperature you are going to divided by the difference of the boiling point and the melting point temperature of both scales. That is, if we're working with Fahrenheit and centigrade, we'll say the difference of the boiling and temperature we are going to, that is, boiling point is 212 minus X, that's temperature we are going to, divided by the difference between the boiling and the melting point, that's 212 minus into brackets minus 32 should be equal to whatever system we are using here must be replicated here. That's here will be 100 minus Y divided by 100 minus 0. So to put it in writing, it would be temperature of boiling minus temperature given divided by temperature of boiling minus temperature of melting. You can keep this formula and generalize it across the thermometers. Now, you may choose not to work with this my own formula. I like this one because it is more reliable. I prefer it. It works accurately for me. Some people you may also choose to use temperature of the given minus the temperature at melting divided by temperature of the boiling minus temperature at melting. Well, whichever one you choose to use, what is very important, the most important thing is consistency. Consistency. If you choose to use this for this, then you must use it for the next one and also for every other one that you'll be using. But if you want to use the other one, you make sure you maintain it. Alright, let's take a question. Our question here says, at what temperature on the Fahrenheit scale will the temperature on the Celsius scale be doubled that of the Fahrenheit scale? What temperature would the temperature on the Celsius be twice that of the Fahrenheit? The first thing to do, of course, is to draw out. Sometimes thinking of these things in our head can be quite confusing, so let's draw it out. I have the Fahrenheit scale and I have my Celsius scale. On my Fahrenheit scale, my boiling point is 212 and my melting point is minus 32. My melting point is 0 and my boiling point is 100. And I'm told to find X where this place is 2X. That is, I should find X when this place is 2X. That is, if the reading is 5 on Fahrenheit, my reading should be 10 on Celsius. That's what we're asked to find. Well, I'm not sure if it is 5 and 10, just using that as an illustration. Okay, let's go ahead into the calculation. Remember, I gave a formula earlier, and that's what I'm working with. I said T of boiling minus given T divided by T of boiling minus T at melting should be equal to our Fahrenheit scale. Rather, it's not minus 32, it's 32 degrees Fahrenheit. An error on my part, omission, sorry. So, as I was saying, T at boiling is generalized. So, generalizing and inserting my values into the equation, I'll have for Fahrenheit scale, T at boiling is 212 and T given is X, that's this one, divided by T at boiling 212 minus T at melting, which is 32, should give me, since I'm generalizing, I'll pick up the other one, I'll repeat the same thing. T at boiling is my 100 here, minus T given, here I have 2x, divided by T at boiling again, which is 100, minus T at melting, which is 0. Then we can solve. Of course, it will be logical to cross multiply and start gathering things together. So when I cross multiply, I'll have on this side 100 multiplied by 212 minus x should give me 180 into brackets 100 minus 2x, and expanding the brackets, I'll have 21200 minus 100x, which should be equal to 18000 minus 360x. Well, let me take all my x's to the left hand side and bring my non-x's to my right hand side. So that would, I'll have 360x minus 100x would give me 18,000 minus 21,200. When I subtract, I have 260x, which would give minus 3,200. So let's divide through by, we divide both sides by as 3,200 divided by 260. I'll get our x to be equal to minus 12.3 minus 12.3, and this is in degrees Fahrenheit because our x here is represented in Fahrenheit. So if we want to check what our degree Celsius would be, it would mean whatever we have here multiplied by 2. That's what our degree Celsius would be indicating. Molecular explanation of temperature. Well, like we have said earlier, told us that every kind of substance contains particles. Those particles are known as molecules, and these particles possess kinetic energy. Have you ever wondered why, when you are boiling your water, the vapor, you see the thing actually boiling like violently? Sometimes it actually can pour some of the strands of water that is being boiled out of the pot. And or sometimes if you are one of those people who has a nozzle kettle in the house, that's all these kettles that has a cover that can cork the pouring part of the kettle, the nozzle begins to nose, it begins to give a sound, it begins to whistle when the water is boiling. Yeah, that whistling it requires a lot of energy. How much energy does it take you to blow a whistle? That's about the amount of energy it takes the boiling water to blow that. And how does it get that done if there is no energy that is being used up? The energy in this place is the kinetic energy. So as we talked about kinetic theory of matter, said that every matter contains particles. This is constant. This is also common to liquids and gases. They contain particles, and temperature change is associated with heat. So when there is the introduction of heat, you experience a kind of temperature change. That temperature change is also a quantifier that we may use to measure the amount of heat that has been injected into a system. The temperature change can be used as a measure for the amount of heat that has been injected into a system. So when you heat a body, it rises in temperature. The rise in temperature increases the speed at which it increases the kinetic energy, which increases the speed at which the molecules of the body vibrate. It increases the number of times that the bombardment of the molecules occur, which is one of the reasons why when water is boiling, it occurs very high. You see, sometimes it will be as though you are pumping the water from the beneath of, you're blowing up the water, like you're blowing some air underneath to push up the water. And you see the boiling effects, and then next you see vapor coming out. So that is what happens in the molecular sense. A temperature increase increases the vibration, and it increases the speed of the molecules, which in turn increases the rate of vibration or the vibrations of the molecules. In this particular topic, we considered heat energy as a measure. Consider temperature measurements, of course, measurement of temperature and heat energy. We talked about heat. We described heat as an energy, and we described temperature as the degree of hotness or coldness. We compared them with each other. Heat is measured in joules, while temperature is measured in Kelvin, Celsius, or the Fahrenheit scale. We talked about the construction of liquid in glass thermometers, and yes, to note, water boils at 100 degrees Celsius or 373 Kelvin or 212 degrees Fahrenheit. Water freezes at 0 degrees Celsius or 273 Kelvin or 32 degrees Fahrenheit. These are the boiling and melting points of water based on the three major liquid in glass thermometers. We also considered other thermometers such as the gas thermometers, the platinum resistance thermometers, and the constant volume gas thermometer, the platinum resistance thermometer, the thermoelectric thermometer, which uses, of course, electric current to measure thermometer, and also bimetal strip thermometers, which will actually take measurements of metal expansion. We looked at the comparison of thermometers, and we decided that the most appropriate thermometer to use in our day-to-day life is a liquid in glass thermometer, because it measures within the ranges which we work with every day. But when we go to measuring temperatures, extreme temperatures, we have other thermometers such as the constant gas thermometer, the platinum resistance thermometer, and the electric thermometer. These ones can measure extreme temperatures, both extreme cold and extreme heat, with a high degree of accuracy. We also talked about temperature scales and conversion within temperature scales, where we give an expression, a formula expression of how to go about this. And we just discussed molecular explanation of temperature. That is, when there is heat supplied to a body, there is an increase in temperature due to the heat supplied, which increases the speed at which the particles of the body bombard each other. The particles get moving faster, thereby increasing the vibration within the body. In a few seconds, some questions will be displayed on your screen. please answer them, and if there is any question you missed out, please go over the video one more time for further clarification.